The sun is anything but a stable yellow ball in the sky. Every day, storms and explosions rage in the solar atmosphere, and these enormous bursts of hot plasma are hurled out into space. Sometimes Earth gets in the way. That's where NASA's new stereo mission comes in. The Solar Terrestrial Relations Observatory is designed to observe these blasts, also known as coronal mass ejections or CMEs, from the Sun in 3 dimensions.
With 3D, we'll really be able to understand what the trajectory of a coronal mass ejection is. And with that, we'll be able to tell even just basic things like how fast is it really going? Is it speeding up or slowing down? And these are important things we need to know if we're going to be able to predict what the impacts of a particular event are going to be.
The effects of these solar storms on astronauts as well as Earth and its technologies is staggering.
CMEs can cause a big electrical disturbance. They have associated with them some very high energy particles. More generally, CMEs affect everything that depends on microelectronics that's up in orbit, like our GPS spacecraft that tell us the positions on Earth, our cell phone communication. If you know one is coming, you can take preventive actions, like put them in safe mode or something like that.
Stereo consists of 2 nearly identical spacecraft. One flies ahead of the Earth, one behind.
1, fire.
They were built by the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, and tested at the NASA Goddard Space Flight Center in Greenbelt, Maryland.
Trying to integrate all of that together on one spacecraft is usually difficult, but with 2 spacecraft, it's even more difficult, more challenging, and in fact more fun from the standpoint of an engineer, because we always want to do something different than we did the previous time. So this was quite exciting for a lot of us.
The spacecraft launch stacked on top of each other. Once in space, they separate and use the moon's gravity to get into their respective orbits. Stereo's main objective is to study and understand CMEs, the most powerful explosions in the solar system. They consist of 1 billion tons of matter traveling at 1 million miles an hour and are associated with solar flares. They usually take 2 to 4 days to reach Earth, useful time to heed warnings from solar observers. But solar energetic particles, which are probably caused by CMEs, move much faster than the solar wind or the CMEs that generate them. These particles can reach Earth as soon as 20 minutes after the start of the storm, making them harder to forecast.
We had a storm in January of 2005 that was very, very intense. I think if the astronauts had been out doing some extravehicular activity on their way to Mars, they could have gotten a year's worth of radiation dose in just a few minutes. So, you know, stereo and missions like that are going to predict solar storms are extremely important.
When Stereo launches in summer 2006, it will join a host of other missions that monitor the Sun-Earth interactions. These include the now legendary SOHO, which tracks overall solar activity, and Polar, which studies the behavior and nature of auroras, the so-called northern and southern lights, created as high-speed particles interact with Earth's magnetic field.